Hey, what's going on, guys? Kamekiki here. So we continue our work on Deobfuscating, world's smallest chess engine written in JavaScript by Oscar Toledo, and we have done quite a lot already. So the source code now have lots of meaningful variable names, but we still have quite a few which are absolutely essential for understanding how the entire engine works. Well, apart from probably this initializing part, which I would take care of a bit later, but here we have a few more variables. So in this video we'll deobfuscate this one, D, and what else, the K variable, and probably, well, we'll see how things go. So without further ado, let's actually start. So I just made a very quick recap on the code before starting this live session, so just to have a bare direction of where are we supposed to be going. So yeah, just to give a bit of a plot to this live stream. Okay, guys, so probably, yeah, let's have a look whether it still works from the previous part. By the way, so it should be capable of playing chess. It is. So well, let's start with this D variable, and well, so what this expression gives us, without looking into the details of what this part does in particular. So as far as this kind of and symbol, so this expression results either to true or false, which means that this D is literally a flag. And the most natural assumption, what in particular this flag can represent, is whether the king has been exposed into a check or not. But just to give more proofs on this assumption, I think that we can write this. Well, let's say somewhere over in here. So let's say. So if we just try to print this all on the way, it would take search ages to complete. So I would probably say if D, so if it is true, I want to do a few things. So I want to say console.log, and sorry guys, just to make sure this is still recording, console log, and so how to call this, let's say incheck, yeah, and I want this D variable, right? And also I want to print the board. So I could see what kind of board position would result in case if this is true. Okay, so just go here, and yeah, probably I can just make a move. Okay, so we have incheck equals to true, and really lots of those. Oh my god, we're still, yeah, it's probably, yeah, still searching for moves. Okay, yeah, so it still takes ages to complete, but anyway, it also gives you an idea that when this incheck is true, that we definitely have a check on the board. So yeah, we're done. We're currently done, I believe. Are we done? Or yeah, we should be done. Or is it still? No, it's not calculating. Or is it? Yeah, now it's fine. Okay, so yeah. So let's say this position, yeah. So we have this incheck variable, which is represented by the D letter, equals to true. And every time we have this, you see like we have the king, the black king in this case, being exposed into a check. So I hope this makes sense. Okay. So I think this is fairly enough to assume that this D should be treated as the incheck flag, so whether the king has been exposed into a check or not. And also, I will now just provide a commentary here as well. Yeah, by the way, I just forgot to provide a few more commentaries. We'll go for this just right in a moment. Yeah, just forgot to do this in the previous part. So, so the current search depth we have, which is the recursive parameter, which gets decreased, I believe. It should be so in recursion, or maybe, I don't know. yeah, the apply has been increased. Well, that's a bit different story. Yeah, but okay, the search depth should be decreased. Okay, that doesn't matter really. Doesn't matter really at this point. So the search depth, at very least, it should be not equal to 0. So this is the point. So no matter what the search depth in particular is, so only if the search depth is equal to 0, we don't care about this part of the expression, because in that case we just we just need to check whether the key like has been captured or not, which happens here. Let's come here a bit later on. So this incheck works only for, I guess we can say, non-leaf nodes, because when the search depth is equal to 0, we actually do have a leaf node. Even though we do some extra work, so here actually we want to make sure that, by the way, hold on a sec. So if search depth, yes, definitely if it's not equal to 0, right? And then, yeah, I just don't want to say something weird in terms of terminology. But the idea here is we need to make sure that when we search, when we kind of end up the search, we need to make sure that the key has not been captured, okay? And for that reason, the score returned by the search should be greater than, and I guess this stands for something like plus infinity. Okay, so in order to give more sense to this expression, we can go to this part, and this means if the captured piece is actually kin, in this case we return this k, which for me personally, well, I think this is something like a maiden score. Okay, so yeah, okay, sorry guys, just let's better go step by step, because this deobfuscation work really needs patience. So just relax by adding some missing commentaries. So a bit of a recap for the previous part. So move offset index, an index pointing to let's say starting index, no, an index where move offsets for a certain piece type starts. Okay, yeah. Offset number, so here a number of directions of where a piece can move, so either 8 or 4. So this has been clarified here as well. 8 or 4, let's say 4 or 8. Okay, then what? The piece type is literally what it is, so it's a pawn, a piece type, so pawn, knight, bishop, queen, king, regardless of color. Okay, and here, so I guess that this is an incheck flag, an incheck flag. So whether the king has been exposed into a check or not. So, and I just want to give some extra commentary to this part. So, well, actually, yeah, this refers to non-leaf nodes. Yeah, because I believe that we get into the leaf node actually here. I'm not sure, it's just an assumption, but this should be the case. So yeah, search depth is at least equal to 1. And yeah, and this would be the leaf node only if the depth is equal to 0, right? So this should be only for non-leaf nodes. So the idea is just before considering generating moves for well, I'm not to be honest, I'm not sure how exactly this incheck variable is going to be used. It's not used that many in that many places, but just want to give, let's say, an incheck flag for non-leaf nodes, and so it's false if this expression doesn't result in Maiden Score. Again, I don't know how to. Well, this actually needs to be checked there out a bit more precisely, but maybe. Okay, let's say an incheck flags that is getting set to true if the king has been captured. Or let's shorten this a little bit. So let's say get set to true if the king has been captured. I think, yeah, this is a bit more reasonable commentary. All right, so what else? Yeah, now let's do our casual routine. So yeah, I don't want this happening anymore. So yeah, I think this demonstration of, well, at very least, well, even if it's not an incheck variable, at very least we know that if it is equal to true, and if we do print the board position, we have a king being exposed into a check. So just to give you an idea behind this assumption. But I really just, this line of code really tells me that we really need to make sure if we have a king being captured or not, because the search returns the score, okay? And if it records the score greater than infinity, then most likely it happens here. And this expression, as I've been mentioned already, is just if the king has been captured, so if the captured piece is a king. We'll have a look at this, and we'll try to break down the expression and manually see how it works, just like we've been doing with the previous expression. So okay, step by step. So let's find replace. So D, I've even been trying to already done this when I was preparing for this series, for this session. So previous. So let's make it incheck space replace next and replace next, and I've missed it somewhere. Okay, there should be one more. Oh, what have I done? D. Don't have it. Okay, maybe it just, so let's have a look. If I broke something, okay, it's not defined. 157. I remember there was in the 3 places in the code. 157 in check. Yeah, now there should be. Oh, 157. Are you kidding me? Oh, yeah. In incheck, save. All right. Yeah, feels like still plain. Great. Okay. So we got this in check, and now let's have a look at this piece of code. So every time we return this k, I also want to say console.log, and I want this in check variable to be printed. So this should be equal to true, right? Because this is the case when we have this situation that the key gets captured. Actually, we're not generating the moves for it here because we don't get here because we just return before everything else is happening, okay? But here, this incheck variable should be equal to true. And also, I want to print the captured piece. So let's say like this, and I want to print the captured piece. And here, so let's take the pieces array and whatever we have at the captured piece. This should be akin. Okay. And if it works, then we go breaking down this expression. So let's have a look. Oh my god, it's not exactly. Yeah, we have the captured piece being equal to kin always, which is absolutely great case, but I'm a bit wondering, why do we have this in check being undefined? Okay. Should I also want to print the board as well? Oh my god, this is why. This is why. Okay. And also let's print the board. So I didn't return anything because of this. Man, don't use semicolon. This should be a single line or the curly braces. Okay, let me just put the curly braces for just make it more clear what's going on. Now I can use this. Semicolon to separate the statements 154. Oh man, we can't. Oh, what have I done? Sorry, what have I done? Weird thing. So it should be here. Oh man, just returning the object. Why do I return the object? Not the case. It's the matter of the if clause, not. Yeah, like this and like this. All right. Yeah. Yeah. For some reason, incheck is still undefined. Well, anyway, we have the captured piece equal to kin, which is really good. And if we print the board, we have this incheck being definitely the case, but I'm just really confused by the fact that this incheck. Do we have D somewhere? Did I miss something? D is not defined. Okay, this is okay. But why it gets undefined? Well, this is a little bit strange because, yeah, so we'll print the proper boards, but captured piece. Okay, but why is incheck is being undefined? Oh, maybe because of this sort of a thing that we returned before. Yeah, that might be the case. So yeah, so let's probably make it like this, and it like this. Okay, so what have I done? Just make a move. What? D is not. Oh, sorry, if incheck. Yeah, it's probably because that additional search call, it just incheck doesn't. Oh my god, doesn't get initialized or something. Not sure why exactly it's undefined. Yeah, now it's much better. So we have this incheck true the number of times for every move that it tries to respond or return, apparently. Not sure. But anyway, and yeah, we have the captured piece. So anyway, I just wanted to show that there definitely there is a kind of like a connection between this incheck variable being equal to true. Meanwhile, the captured piece is the king. Even though it doesn't seem that, well, actually this incheck flag doesn't get involved in, by the way, it doesn't get directly involved in this part or here. Okay, but anyway. Okay, let's probably log the score as well. So let's say score and this K. All right. And okay, so the score is always equal to this constant. Well, actually, yeah, this might be different depending on the apply, I believe. And here we would introduce yeah, another still calculating or what? It's always this. No, here is different. So I'm not sure, but this is probably, yeah, hold on, 39936 344 936. Well, not, it definitely depends on ply. I'll now show you why, but it's probably, okay, guys, the formula that calculates this K would make sense. So we have a look at the K. We have some constant, which I have no idea what this means, minus H, and all this left, bit shift to the left to 9 elements. So this can be treated as the multiplication, which is just done faster. Well, seems to be just to give a number that is greater than this value. So yeah. So, well, actually I said that the incheck doesn't have a relation to to this the matter of king being captured, but actually it is, because otherwise if this expression doesn't return true, is that possible somehow? The search returns 0. Oh no, it's not a matter of, sorry, it's not a matter of 0. So if it should be just equal than this big number. So yeah, and in this case, so this yeah, I'll just now show you this, guys. So we have the values like, oh man, so we have the values like this, okay, and if we just say 1e8, no, 1e4, I'm sorry. So this number is greater than this one. So in case when we have this incheck being equal to true, we have this score, and it's greater than this 10 thousandths, right? So probably, well, I think that 10 thousandths might be the Maiden Score limit. So it's not a plus infinity. I think this means infinity actually. I still can't figure out whether it uses. Oh no, it can be probably neither fail hard nor fail soft because it's not an alpha beta search. So we don't have any boundaries. Yeah, sorry, that just never mind. Okay, so at least, but this seems to be like the Maiden Score. Okay, so if it is in check, so in check gets true in case if the score that we get, this one here is greater than this one E4, which stands for 10 thousandths. Okay, I think this is fairly enough for now. So well, it's not really aligned that great, but okay. So K is the score, but what kind of score? Okay, so let's have a look at this H now. So I've already revealed that H, well, at least it works like apply. And if we have a look at what happens here, so H is the mysterious argument that I have no idea how it works. But actually, we have a look what happens here. So every recursive call, it gets increased by 1. And this represents the exact behavior of what happens to the gameplay. And also, it's very reasonable to subtract the gameplay from the eventual Maiden Score to get the closest distance to the mate. So to consider the shortest move sequence to get to the mate, which happens here. So we do this minus H, and then we do this kind of like multiplication. So, and another thing to consider, so here, let's say, well, we can actually try to play, well, no, that's better. I just show you this in the full-blown mode. So let's just say console.log. It takes kind of long to execute, but anyway, so we just call it ply and make it plus H. Just want to give you an idea, guys. So for those of you who has been dealing with chess programming, you definitely find this to be really familiar. Reference error. Console. Oh, sorry, just a typo. So console. Okay. So it takes a bit long, but we do increase the ply and decrease it back. So just like goes upwards and then goes downwards as well. Well, usually I've been using ply as the variable. In my engines, ply wasn't the variable that is passed as the argument recursively to the recursive function call, to the recursive search call. Even though I personally consider this to be a really good idea. It works like a charm, and yeah, it doesn't take the global scope, which is good. It was taking the global scope in my experiences, in my previous experiences. But actually, when it had been coming to minimalist engines like Toyfish, my recent series on absolute beginners, chess engines for beginners in Python, I didn't use the ply at all, but bear in mind the fact that the engine wasn't intended to be searching deeper than the depth of 3 plies. That was fairly enough to figure out where the mate was. So yeah, we're still searching because yeah, this log into console takes ages, so just take time to talk for a while. So I wasn't using that because the way how my engine was written didn't intend to go to the depth, let's say deeper than 4 or 5 plies. Therefore, there was no actual practical need for keeping track of the ply and finding for the closest distance to the maiden position. So I've dropped that for simplicity. And for this engine, it's absolutely the same. So hence it doesn't use the alphabet search. It just seems like a pure eninge brute force algorithm. We're going to be revealing this as well later on, but at very least we don't have the alphabet boundaries being sent along with the recursive call. That's why I assume so. But still, Oscar Toledo does use this ply to actually be able to find this closest, the shortest path to the maiden sequence, like the shortest maiden sequence possible, even though it's hard to imagine that this engine is going to be running, say, 6 ply depth, because it really takes too long to complete. Okay, so yeah, it's really cool to have this ply. For me personally, it feels like a bit of a redundancy, but it's actually, oh my god, my computer is hanging. I'm sorry guys. Well, I probably, well, you just trust me that the ply are just gonna be getting down later on. So I'm sorry, just want to horrible thing is happening. When I wasn't using where it was master, you can still hear me. I just want to drop this. Okay, just close the browser. Yeah, printing the plies was really a bad idea, to say at least. Come on, can you please close the browser? I can't even pause the video recording because it just hangs completely. Okay. Okay, at least got my browser being closed finally. All right. Okay. So, oh my god, it takes. Sorry guys, just want to make sure that I've killed all the process properly, so there is no Chrome idling. Yeah, this was a bad idea to log the ply into the console. Oh my god, why it's so laggy? I just probably stopped the recording. I hope I can do this to restore the system. Hold on guys. Okay guys, so we're back. Yeah, I'm sorry for this inconvenience. So yeah, okay, so disable this the printing off the search ply. So let's go and search for this H, and well, can we place it like maybe like this, and let's just call it search ply. Okay, and then starting from here, next, and replace, next, replace, next, replace. Oops, Control Z. Oh yeah, okay, replace. Yeah, it seems like making big sense now. next. Yeah, and if I did everything properly, it should still be capable of playing chess, hopefully. So yeah, just let's get rid of all of this unnecessary comment trees, like this one. And by the way, here we swap side to move. Yeah, should have been added this a long time ago. Okay, so search ply, search depth. Yeah, starts making perfect sense. Okay, and now let's make sure we're still playing. Whoa, missed somewhere. 177. 177. Okay, yeah. So search ply. Save. Go again. Oh, 168. All right. Search ply. Man, 180, too many. 180. Okay guys, so at very least, yeah, we get it back working. Yeah, just let it search. I mean, like, let it print. We don't care about it for now. So let's go and check our king capture code. So captured piece, so it's a piece, it's not a type. So what do we do here? Make it -2 and bitwise end with 7. So let's try to do this with a couple of pieces just to check it out whether this assumption is working. So we have 10 let's start with 2. Oh, does it work only for a black king? This is interesting. This is really interesting. Does it only work for a black king? But how does it handle the white king? Is there a different mechanism? Yeah, it seems like it's designed to for white king, really, to track only the black king, because we have this 2. Yeah, I didn't actually check whether this works for the opposite side for white to move. It actually has to, because yeah, otherwise the search would be producing the illegal moves, like generating the moves after the king being captured. But anyway, so -2 and bitwise end with the 7. So I'm not sure about the order for this, so let's check the order. So let's say 2 -2 bitwise ended with 7, right? So what this results as a 0, and if we just say 0 bitwise ended with 7, it also should be resulting 0. So I guess first it executes this part. Okay, let's say 1 bitwise ended with a 7 equals to 1, and let's say 2 -1 bitwise ended with a 7. Yeah, so I think this goes first, and then gets this bitwise end operation. So it gets to it is equal to 0. This expression equals to 0 only in case if the captured piece is the black king. But I'm just really wondering. Okay, can I say, so here, can I say if captured piece is equal to Whiteking, which is 10, right? Is equal to 10. is this gonna print anything at all? Yeah, it does. So yeah, so it gets the captured. So we get to this part of code for Whiteking as well, which is correct from the logical perspective. So if it's not, or otherwise, if this expression is equal to 0. Hold on a sec. It would just take, yeah, hold on a sec. So this might be just a smart hack. So 2 minus 2, bitwise ended with the 7. Bitwise ended with the 7 is gonna be 0. Bitwise ended with the 7 is gonna be 0. But what if we say 10 minus 2? Okay. Bitwise ended with the 7, and so this would be 8. Bitwise ended with the 7, and yeah, I need to convert this to binary, so 8. Bitwise ended with 0, 1, 2, 2. Oh, right, and this gives us a 0 as well. Okay, is it? Yeah, and for all the rest of the pieces it won't be. Yeah, it's a very smart encoding. So this the current piece encoding allows this fascinating bitwise operations, allowing to figure out whether the type is a kin. And let's say in Gerd Miller's implementation in his Micromax, the matter of a piece type was just the matter of bitwise ending with the last 3 bits, like the first, the second, the first, the fourth, and the eighth. No, the first, the second, and the fourth bits, which results 7 at most. And that was the way to distinguish by the piece type. While here, Oscar Toledo uses a separate expression for this. Okay, so one last thing I want to check is, just want to double check this on a calculator. So we have this 8 bitwise ended with 7. Okay, and we get 0. Perfect. So that's how we can answer the question whether the captured piece is a kin. So here I can say if either white or black kin has been captured, not captured, let's say, yeah, has been captured. So let's say it's not being captured, is gonna be captured, is going to be captured, is going to be captured, and here we want to return the Maiden Score. Return Maiden Score. Okay, and the Maiden Score, so this should still be capable of playing chess, right? Okay, and the Maiden Score, this K, so this is how we come to the Maiden Score. So we just return the Maiden Score, we're no longer generating the moves, and this works exactly the same in as it was done in Micromax by Gerd Miller. Well, conceptually at least. So here we can call this the Maiden Score. Okay. So literally what it is. So this is a shortest. Let's say a Maiden Score ensuring shortest distance to the mate based on the ply that we got here. So we just use the search ply to define the shortest distance. Okay. Not really sure why this 78 constant is needed. What is this 78 constant is needed for? Well, it's clear about the multiplication, but why not just say something like 10 thousandths minus search ply as people regularly do. Maybe this have some hidden sense I've no idea about, so that's not really clear that much at the moment. Okay, but anyway, so yeah, Maiden Score, and I just want to search for all the instances of the k, and yeah, only a couple of places basically. So let's say Control H, and this is gonna be the Maiden Score. Oh man, what's wrong? Maiden Score. So okay, previous. All right, so starting from here, I guess. Place, replace, and this is it. Okay. Yeah, still working. So the variable renaming seems like it was successful. Great. Okay, so we have deobfuscated almost all the search variables, so we still have two variables. This mysterious s, I still don't know about what exactly it does. And so, well, this is something like a score returned by the recursive call, definitely, but it also does some trick here. I'm not sure what exactly it is done and what in particular, so probably need to just print the value of s right over in here, which we will go for at the moment. And or probably we could have leave this to the next part, I don't know. Yeah, probably. And this n, which stands for minus infinity, I guess that's the minus infinity value, which exceeds the Maiden Score, but well, I'm not sure why that is done. Okay, maybe. So score kind of like minus infinity, minus infinity, and this is the mysterious s. Yeah, guys. So probably I need to make a bit more research on this, because if I will start guessing now, it takes another couple of hours, and I don't really want to be torturing you with this sort of a thing. So I think we done enough for this part, and as long as we reveal this next three variables, so just the proper way to call them, this and the s and this small s. Okay, small s. I didn't mean that, I'm sorry. Small s. Small s but big tits, right? Or in the country, what would you consider? Okay, yeah, it's just to make sure that you're watching the entire video. You will let me know in the commentaries if you do. Okay. All right, so what else do we have here? Okay, yeah, I think, yeah, also this small b and big B. Small boobs, right? I'm sorry. Okay, so I guess this would be something like best source and the best target score, because we do involve them it's a bit strange way, but at least at a glance, but we do involve them when we actually render a board. So I can assume that this variable and just actually holding the best source and the best target score so far, and this looks like at very least this is the place for the eninge for the brute search, brute force algorithm. Like, just if we have a better score, then. But yeah, I'm sorry guys, just I really need to dive into this in the great details, for otherwise it's really hard to say something, and I don't really want to be assuming things. Yeah, so let's stop here. Yeah, thanks for watching, and we're coming to the end. Well, it probably takes a few more episodes, but I still want to bring some light on how this masterpiece variable initialization works at start, because it's still a bit of a mystery for me, especially how this can, like, if this is the target source squared and how on earth it correlates with this one. So it's a bit of a mystery still, but anyway, we have deobfuscated the most of the source code so far, and I think that by the end, so by the time when, well, all the variables would be deobfuscated completely, entirely, now probably we can go for a bonus episode trying to bring all the things together, if I'm smart enough to figure that out how it works in particular, and trying to walk through the entire source code just to give an idea of how all works in a bundle. Well, okay guys, so this is it from my side. Thanks for watching. Until the next time, and take care.